We will continue the internal forces in beams. Just to remind you what we did so far. We learned that we have a beam and we have a specific point in this beam, and we are looking for the internal forces, normal, shear, and moment only at this specific point. So the problem in this kind of problems will ask you to determine or to calculate internal forces at only specific point. The second part in this topic, we don't have a specific point. We don't have a specific point. We are going to draw the internal forces through the whole length of the beam. So it's a different scenario. So we have one problem saying draw and another one called calculate or determine. This one at a specific point, but this one will draw the internal forces, axial force, shear force, and the bending moment for the whole beam, not a specific point. Let's start. We learned that for internal forces, we have three kinds of internal forces. Normal force. This one will be piece of cake. Very easy. Second one, shear force. Piece of cake. Very easy. Don't worry. The third one called bending moment. It's a piece of cake. It's very easy if you draw shear force right, because bending moment depends on shear force. So if your shear force is wrong, bending moment will be wrong. What's going on? We have some relationship between shear and the applied force, between bending and shear force. We have few relationship, just for your information. Keep it in your mind. Shear is integration of load. So shear equal integration of load. Wow, integration, that means we will do integration and the mathematics calculation, all of this stuff. No, just for your information. Shear is integration of load. That means if you have a load, you can integrate it to figure out the shear force diagram. The relationship between moment equal integration of shear. So in the problem, I'm gonna give you a beam with load. So you will integrate this load to figure out shear. Once you figured out the shear, I will integrate this shear to figure out the applied, the bending moment diagram. So just keep in your mind the relationship between load and shear, the relationship between shear and moment. Just to remind you, the main target for this part of this topic, we are looking to draw axial force. Axial force is a different scenario, different story. Shear force and the bending moment diagrams. Just to let you know, we have a relationship between load and shear, and another relationship between shear and moment. Integration of load equal shear. Integration of shear equal moment. We have a load. Load will be given. If you look to the homework, we have a load. We have a load. So the load is given. So go ahead and integrate these loads to figure out shear force diagram. Once you get the shear force diagram, I can integrate this diagram, which is shear, to figure out the bending moment diagram. Looks like integration. Some of you hate anything related to math. Me too. But the story is very easy. Don't worry. I'm just giving you some information. Steps of solution. We have few steps. If you follow these steps, we can draw 3 diagrams. One called normal force diagram or axial force diagram. The second one called shear force diagram. The third one called bending moment diagram. First step, you have to calculate reactions. Reactions. And without reactions, you cannot solve the problem. If your reactions are wrong, everything will be wrong. So first step, calculate reactions. Second step, how to draw shear force diagram. Shear force diagram can be written like this: shear force diagram. We can go up if the force going up, and we can go down if the force going down. In only one condition, if you start from the left side. Very easy. This rule is very important and very easy. Just you are playing. Please, if you have a force going up, go up. If you have a force going down, go down. But you have to start from what? Left side. Remember, just remember, left side. Left side. At any free end and the simply supported end, the shear will have a 0 value. The shear will not change in X direction until there is another load. If there is a distributed load, the change in shear is the area under the distributed load. I cannot figure out what's going on, but let's start this example. The example did not give you a specific point because the example asking for drawing axial force, shear force, and the bending moment diagram. Regardless what are the required in this example, anybody can remind me what is the first step? Reactions. Module number 5, reactions. So regardless, you can draw or you cannot, the first step is reactions. So A is pin support. So we have 2 reactions. One vertical, YA, one horizontal, XA. B is a roller. So we have only one reaction, YB. To figure out reactions, we have 3 equilibrium equation. Summation f of x equals 0. What forces do you have in X direction? Please don't forget any. We have XA. Anything else? No. XA equals 0. This reaction equals 0. Summation f of y equals 0. What forces in y direction? We have positive YA. We have positive YB. We have negative 20. We have negative 20. Anything else in y direction? No. Equals 0. If you simplify this equation, YA plus YB will equal 40. 2 unknowns. The third one, summation moment at any point equals 0. Do you remember my recommendation to take a moment for reaction? Yeah. Take a moment at one of the supports. Which support? with larger number of unknowns, I believe will be A. And I'm gonna assume this direction is positive. If you take moment at A, okay, XA times 0, we don't have distance. YA times 0, we don't have distance, plus 20 times 6, the first 20. The second 20 times 12 minus YB times 15 equal 0. I believe until this moment, some of students cannot figure out the actual distance. Guys, I'm sitting at A, and here is the first force. The distance in between is 6. The second force, 20. The distance in between this force and the point A is 12. The third force, YB, time the total distance is 15. The only unknown, because this term will be cancelled, this term will be cancelled, the only unknown here will be YB. How much? It will be 20 kilonewton. No, I'm sorry, guys. No, it's not 20. 20 times 6 plus 20 times 12 divide 15, 24. If you go back here and put YB 24, I can figure out the value of YA. It will be 16 kilonewton. So this reaction YA equals 16, and this reaction YB equal how much? Uh, 24. Any question so far? Thank you, Mitchell. Any question so far? Looks good. In trusses, I focused on reactions. On beams, I'm focusing on reactions. In module number 5, I spent 2 weeks on reactions. After all of this time, during the exam, if I find someone cannot calculate reaction, he does not deserve to pass this course. Reactions means A, B, C, D. If you are trying to learn how to read, you have to learn letters. If you would like to learn engineering mechanics, you have to learn how to calculate reactions. So please pay attention to reactions. Second step. I'm done with calculate reaction. Second step. If you have a force coming up, go up. If you're having a force coming down, go down. But start from what? Left. If you would like to draw shear force diagram. But before shear, I would like to draw normal force diagram or axial force diagram. What should I do? You will draw vertical lines like this, like this, like this, and like this at anything, any location on the beam. Then I'm gonna draw 3 copies of this beam. The first one will be for a normal force diagram. The second one will be for shear force diagram. The third one will be for bending moment diagram. So please, during the exam or the homework, if the beam is given in this direction, please try to avoid to write anything here. Just write on the left side to calculate your reactions. Don't try to write anything below the given beam. Why? Because under this beam, I'm gonna draw 3 copies of the beam. The first one will be for normal force diagram. The second one will be for shear force diagram. The third one will be for bending moment diagram, like I'm doing right now. So your calculation on the left, your drawing will be on the right under the given beam. Try to be organized. Okay? Okay. Just a reminder, if we go back, and one more. Do you remember which force making axial force or normal force? Which force? The horizontal one or the vertical one? Neither. Not horizontal or vertical, but the force parallel to the member. And if this force pushing, it will be compression, which is negative. And if this force pulling, it will be tension, which is positive. Do you remember that? Okay. Let's go back to our example. My question is, which force on this beam parallel to the beam? Which force parallel to this beam? Is it YA? Is it YB? Is it 20? Is it 20 or XA? Which force parallel to the beam? Any answer? Which force? Which reaction? Thank you. That makes sense. XA. Okay. Let me ask another question. What is the value of XA? And XA is pushing or pulling the beam. If you answer this question, you can draw normal force diagram. The first question, what is the value? 0. I don't care about the remaining question because the value of XA is 0. So normal force diagram will be 0. We don't have any force. We don't have any value of forces parallel to this beam. That means we don't have normal. If you have a value, we will have. But if you don't, your normal force diagram is 0. Just piece of cake. Very easy. Please write 0. Don't leave the diagram without anything. No, let me know 0. If you have a value, I will let you know what will happen. Shear force diagram. Second diagram. I will go up and I will go down based on the force. But just to remind you, just a reminder, which force making shear? Do you remember? Is it horizontal force? Vertical force? No, not horizontal or vertical, but force perpendicular to the beam. The force perpendicular to the beam. So I will focus in this example on YA, 20, 20, YB. Why only these forces? Because these forces are perpendicular to the beam. How can I draw shear force diagram? Very simple. Very simple. Where is your left? I'm sorry? Where is your left? You are standing here. And looking, you are standing here and looking to the screen. Where is the left end of this beam? Where is the left end of this beam? Here you go. Left end of the beam. Please go ahead and start from there. What do you have at this start? We have YA. Going up or going down? Going up. Please go up. How much? 16 YA. So, how to draw shear? Please start from left side. Go up if the force going up. Go down if the force going down. On my left, I have YA going up. So I went up 16. Walk. I'm sorry, walk forward. Walk forward on the beam. I am here at 16. Do you have anything when you are walking? No, nothing. Nothing here. So keep walking. Keep walking. You are at 16. What did you find? 20. We have another force, 20. Going up or going down? Going down. Please go down. How much? 20. But I am here at 16. Okay, go down from 16, 20. So I will go down until reach 4. Keep walking. Do you have anything? No. I am walking here. Nothing. So keep walking. Keep walking until this point. I am here at 4. Negative 4. What do you have? I have 20. Going up or going down? 20. This 20. Going up or going down? Going down. I am down at 4. Please go down more. How much? 20. I am down at 4. Go down more. 20. So I will reach 24. Keep walking. Nothing. Nothing here. Until I'm reaching the end. I am at 24. Okay. What do you have at the end? I have reaction. Going up or down? Up. How much? 24. Remember, you are at 24 negative. I need to go up 24. I will reach to 0. Once you are done, I draw shear force diagram. It's a joy. You are playing. Do you know there is a game looks like this, go up or go down based on the direction of the force. I'm gonna repeat it one more time. Why? Because it's very important. If you draw shear correctly, the next diagram will be correct. So please pay attention. Please pay attention. To draw shear force diagram, I have to start from left. So please, where is the left side of this beam? Here you go. Start from there. What do you have at this point? We have XA, we have YA. Which one? YA, perpendicular to the beam. So this one related to shear. YA is going up, so please go up. How much? 16. So remember, if your reactions are wrong, this diagram will be wrong. Okay, I went up 16 based on YA, and then keep walking toward the beam. Keep walking inside the beam. So I'm walking. If you have any force, please follow the force. Do you have any force during your walking? No, nothing. So keep walking constant until, remember, you are at 16. Until you reach this point. Do you have a force? Yeah, I have one. How much? 20. Going up or down? Down. So I need to follow this force. But remember, you are at 16 and I would like to go down 20. So I'm gonna reach -4 on the other side. So this total height is 20. 16 in the positive side and 4 in the negative side. After you are done with the value, please keep walking. If you don't have any force, keep walking until you reach the next point. Do you have a force? Yes. How much? 20. Which direction? Down. So I will go down by 20. You are at -4 and I will go down more 20. So I'm gonna reach to 24. Remember, this height, 20. After you are done with the value, keep walking. until you hit the end of the beam. What do you have? I have a reaction YB going up. So please follow the force. I will go up. How much? 24. So I will go up 24. I will hit 0. This diagram is positive. This diagram is negative. This diagram is negative. So guys, what do you think? Normal force diagram, Aaron. Normal force diagram following what is the value of XA. If you have a value, you have a diagram. If you don't have a value, your diagram is 0. No relationship. There is no relationship between shear and normal. We are talking about different story. Until this moment, anybody has any concern, any issue, any problem, any question related to shear? I know you will ask if we have, we will cover all the cases. Don't worry. But until this moment, do you have any issue? Do you have any question? Okay. How to draw bending moment? So I'm gonna draw bending moment at this location. Yeah, let's do it here. Bending moment diagram. For bending moment diagram, at free end and at simply supported end, the moment will have a 0 value. At the fixed support, the moment value will equal the reaction moment. These 2 points are very important. What do you think? We are in the first one or second one in this problem? Do you have fixed support in this beam? No. No. Remember, I'm gonna start also from left. I'm gonna start from left. Okay. My question is, do you have fixed? No. So forget this rule right now. I am in the first one. Free end. We don't have free end. We have simply supported. Simply supported means hinge or roller. Simply supported means hinge or roller. Yeah, we have hinge or roller at this end. We have hinge. That makes sense. What is the value of moment? What is the value of moment? 0 value. So the first value here of moment will be 0. One of you will ask me a question. If we have a fixed, okay, follow the second rule. Fixed support. If you have a fixed, you will have a reaction moment. This reaction of moment will be the value. If you don't have fixed, which means hinge or roller, your value will be 0 all the time. These 2 rules are very important. If you have fixed or if you have simply supported end. We have simply supported, it's a hinge, so your value will be 0. What else? We are looking for next value. Where is the next value? Will be here. Where is the next value? Will be here. Where is the next value? Will be here. The first value is 0. What is the second value? This number 1, number 2, and number 3, and number 4. Let's do it for number 2. It's very easy. Just a second. Okay. M2 equal M1 plus area of shear between 1 and 2. I'm sorry. We are looking for what is the value at position number 2. What is the value of moment here? Equal previous value. What is the previous value for this point? Previous value is M1. What is the value of M1? 0. Plus area of shear force diagram between 1 and 2. Between 1 and 2, we have shear force diagram, this one. What is the area of this diagram between 1 and 2? It's a positive 16 times 6. Can you tell me what is the value? Positive 96. So the value here will be positive 96. Anybody can tell me what is the value of moment at 3? What is the value of moment at 3? Equal previous moment, which is M2, previous point, M2, plus area of shear force diagram between 2 and 3. What is the value of M3? Equal. Previous value for M3 is positive 96 plus between 2 and 3 we have shear force diagram negative. Can you tell me what is the area of this diagram? Negative 4 times 6. Your value will be 96 minus 4 times 6. Your value will be 72 positive. So we have here a value, looks like here, for example, how much? 72. Guys, in your exam, don't remove your reaction calculation. I don't have space, so in your exam, you have more spaces. Anyway, so anybody can tell me what is the value of M4? Yeah, M4 equal previous value M3 plus area of shear force diagram between what? 3 and 4. What is the previous value for M4? Is positive 72 plus area of shear in between 3 and 4. Yeah, we have area here, this area between 3 and 4. How much? This area is negative. How much? 24. It's a rectangle. Time 3. Your value will be 0. That's fine. 0 is a value. After you are done with M1 and M2 and M3 and M4, I can draw lines. This diagram, which is positive, called bending moment diagram. Very easy. But we have a big concern here. This bending moment diagram depends mainly on shear force diagram. And this shear force diagram depends mainly on reactions. So try to think or imagine if my reactions are wrong, your shear force diagram will be wrong. Your bending moment diagram will be wrong. Any questions so far? Okay, one of you will ask me a good question. What is the benefit of these diagrams? These diagrams will give you the internal forces at any point inside this beam. For example, if I'm asking about this point, this specific point, anybody can tell me what is the N value, what is the V, what is the M? How can I get this value at this specific point? Very simple. Just to go down, the normal force is 0. The shear force is 16. The bending moment will be this value. Another one will say, hey, can you tell me what is the value of moment? Internal forces at this specific point? Yeah, I can tell you. Go down at this point in these diagrams. Your normal will be 0. Your shear will be -4. Your moment will be this value. So drawing diagrams will give you any value at any specific point inside this beam. One more example. For this example number 5, we are looking to draw axial force, shear force, and bending moment diagram for the shown beam. First step, as usual, to figure out the reactions. So we have here a reaction YA, it's a roller. A is a roller. B is a hinge, so we have two reactions, YB and XB. Remember, 6 kilonewton meter as a moment is given. So let's start to figure out the reactions. We have 3 equilibrium equations. The first one will be summation f of x equal 0. We have positive 8. We have negative xb equals 0. From this equation, I can say xb will be 8. So this reaction equal 8. Summation f of y equals 0. We have negative 6. We have positive ya. We have negative 8. We have positive yb equals 0. So I can simplify this equation. Ya plus yb will equal 14. The third equilibrium equation, summation moment at any point equals 0. I highly recommend to take moment at B, and I'm gonna assume this direction is positive. Taking a moment at B, so YB times 0, XB times 0, we don't have distance. These are forces, need distance, but we have a moment 6. Negative, opposite to your assumption. This moment does not need distance, so I will not multiply this 6 by any distance. Plus 8 times 2, negative YA times 4, plus 6 times 8, plus 8, this force 8 times 0. Remember, your force and your distance must be perpendicular. So this force is horizontal force. We don't have vertical distance between this force and point B. Anyway, this equation equals 0. This term will be cancelled. This one will be cancelled. And this one will be cancelled. The only unknown in this equation will be YA. So the value of YA will be negative 6 plus 16 plus 48 divide 4, 14.5. So YA equal 14.5. If you put here YA equal 14.5, that means YB will be negative 0.5. What does it mean? What is the meaning of negative 0.5? Do you remember? Negative value means wrong assumption. What does it mean? You assumed the wrong direction for YB. You assumed it up? No. YB will be down. How much? 0.5. Second step, I'm gonna draw vertical line here, and the vertical line here, and the vertical line here, and one more here. And then I'm gonna draw 3 copies from the beam. The first one for normal force diagram, the second one for shear force diagram, the third one for bending moment diagram. Just a reminder, which force will cause axial force or normal force diagram? The force parallel to the beam. So which force? This one. How much? 8. This force pushing or pulling the beam? It's pushing. So 8 will make normal force and compression and negative. Compression means negative. Negative means you have a diagram like this. Negative. This value is 8. This value is 8. Shear. I will go up. I will go down. Based on the force, I will go up if the force going up. I will go down if the force going down. But you have to start from left. Excuse me. What do you have in your left? I have 6 kilonewton coming down. So I will go down by 6. Keep walking. Nothing, nothing. Keep walking at 6. Until this point, we are at 6. We have YA coming up. So I will go up how much? 14.5. So I will go up 14.5. So until you reach, I think 8.5. This value will be 8.5. Keep walking until you reach this concentrated force. Remember, you are at 8.5. I need to go down how much? 8. If you go down 8, I will reach 0.5. Keep walking. You are at 0.5. Until the last point, I will go down by 0.5, which is reaction YB, which is down. 0.5. So this one will be positive. This one will be positive. This one will be negative. For bending moment diagram, I'm gonna start from left. For normal, we started from left. For shear, we started from left. For moment, we started from left. This side or this point is free end. We don't have any moment. We don't have any fixed support. So your moment here will be 0 at point number 1. We are looking for moment at point number 2, moment at point number 3, moment at point number 4. Let's start. Moment at point number 2. Do you remember the rule for moment? Moment at any point equal previous value, so I'm looking for M1, plus area of shear between, area of shear in between. Okay, previous value for M2 is M1, 0. We don't have moment here. Plus area of shear between the 2 points. The 2 points, we have area of shear, this area. It will be negative 6 times 4. Your value will be negative 24. Negative means down. 24. M3, moment at the next point equal previous point, which is M2, negative 24, plus area of shear between the 2 points. What is the area of shear between the 2 points? We have positive area. How much? 8.5 times 2. This value will be negative 25 plus 8.5 times 2, negative 7. So the value here will be negative 7. The last moment M4 equal previous value, which is M3, negative 7, plus area of shear between the 2 points. We have area, little area here, positive 0.5. This height is 0.5 times 2. This value will be negative 6. So we have a value here, negative 6. Finally, I'm gonna connect between this value and this value, this value and this value, and this value and the last value. And this diagram will be negative. Here is the bending moment diagram, shear force diagram, normal force diagram. For your information, if you are looking for any value at any point, for this point, for example, you can go down like this. So this value is the value of normal. This value is the value of shear. This value is the value of moment. So I can figure out the values of internal forces at any point through this B. Okay?